Hey, what's up, you guys? Welcome to another episode on the Incredible Academics YouTube channel. Guys, today it's the 8th of January 2024, and we are starting a new chapter today, and that is compound angle identities. Compound angle identities. Identities. So this is trigonometry. So it's just a continuation of what you guys did in grade 11. Okay. So what is compound angle identity? So the first thing that we're going to do is we're going to draw a Cartesian plane quickly. We are just trying to prove the compound angle identity. So here's a Cartesian plane. All right. Here's a Cartesian plane. And then we're going to draw a unit circle. A unit circle, it's simply a circle which has got a radius of 1. In other words, from the center of the circle to the circumference, that's just 1. So here, it's 1, and then here it's -1. Even here it's -1. This is your y. This is your x. Okay. So now the first thing, I don't know if you guys are going to be able to see, but I'll try my level best. So what we're going to do is we're going to, draw some radii just to indicate the different angles. So the first angle that we're going to have, so let's say we've got this over here, and from here to there, this angle, we can call it what? We can call it beta. All right. Seems like this is too small. Okay, let me do this so that you guys can see properly. So let's have the unit circle like that. There's the Cartesian plane. All right. Okay, this is slightly bigger, and hopefully you're not going to be able to see. So now look. This is your y, this is your x. All right. So now we know that this is a unit circle. In other words, the radii is 1. 1 here, this side is -1, -1 as well. Okay. So the first thing that we're going to do is we're going to draw a line from here, a dotted line. And then this dotted line, it makes an angle of alpha. Not alpha, but beta. So from this point to that point, that's beta. So we're going to have another line from here to the circumference of the circle, and the angle that this line makes, we'll call it alpha. Okay, alpha. So now the question is, what is the angle between these two lines, the radii? So we'll call this one line A, and this one we'll call it line B. And yes, so what is the angle between A and B? So simply the difference between alpha and beta. So if you subtract beta from alpha, then you get the angle between A and B. So this here, it's going to be the angle between there, it's going to be alpha minus beta. Okay, so let's draw another line right from here, which makes the very same angle with the x-axis. Okay, so we are drawing another line, goes to the circumference. So this line over here and the x-axis, so this line we'll call it C, and this point, the x-axis we'll call it D. So this line, x-axis here, we'll call it D. So we'll say that this line C, the radius, and the D, the other radius which lies, so this is O, the other radius which lies on the x-axis, it's D. Okay, so the angle between the C and the D, right, we'll assume that it's alpha minus beta, just this angle here, right, that angle over there. So we'll assume that it's alpha minus beta. Okay, so what we're gonna start doing is we're gonna start, creating triangles, and you will see why. So we just join that perpendicular line over there. We join another one. Right. Another one here. Right. Let's join another one here. Cool. All right, and because this lies on the on the x-axis, and this is a unit circle. I mean, it's easy to tell that from here to there, it's just 1. So the coordinate there, it's going to be 1 is to 0. Right, it's going to be 1 is to 0. Even this side is going to be minus 1 is to 0, but we're not interested in that. But anyway, let's focus on these triangles here that we've created. Okay, so if you check, because remember the coordinates are always x is to y, even here the coordinates, it's x is to y. Here as well, it's x is to y. So now let's check quickly. So because we know that this triangle here, it's got the angle beta, right? It's got the angle beta. Okay, so now meaning that y, right, over OB, right, y over OB, what trig ratio is that? And I hope you know what OB is, because OB is from the center of the circle to the circumference of the circle, and we're dealing with a unit circle, so you can already tell the length of OB, OA, and OC. This is a unit circle, so that is self-explanatory. So y over OB, that is opposite over hypotenuse. I hope you said the sine of beta. Okay, and because OB is 1, this is just going to become y is equals to sine beta. Okay, so meaning that y over there, it's sine beta. Also, let's focus on the x. Remember, we're focusing on the y, let's focus on the x. So we know that x over OB, which is the hypotenuse, is equal to the cosine of what? Of beta, the cosine of beta. Remember, this line makes an angle of B with the x-axis. Okay, so the x over the cosine of B, over OB is equal to the cosine of B, but OB is 1. OB is 1, so x is simply equal to the cosine of B. So the coordinates here, it's going to be x is to y, by x is cosine of B, and y, it's the sine of B. There you have it. So let's go figure out the coordinate A. Okay, and we're going to use the fact that this line over here, OA, makes an angle of alpha. Remember, from here to here is the angle alpha. So now let's use trig to figure out what is x and what is y. Okay, right? So we focus on this triangle now. All right, this triangle. So remember the alpha minus beta, it's just the angle between OB and OA, but the angle that OA makes with the x-axis, right, from here to there, it's alpha. So we need to figure out what's the x and what's the y here. Here, so x here, now this is the y, so this y over hypotenuse, which is 1, remember OA is 1, so y over 1 is equal to, remember y over 1 also, it's opposite over hypotenuse, so that is equal to the sine of alpha this time around. Also, okay, so this simplifies to what? Y is equal to the sine of alpha. That's cool. And then now let's check the x over there, over the hypotenuse. Which trig ratio is that? So x, remember, in this triangle here, this is our x. X over 1, because the OA is 1. That's the cosine of alpha. Alright, therefore x is just cosine of alpha. So meaning that the coordinate A, it's basically x is to y. What is x? X is cosine of alpha. And then y is sine of alpha. Okay, so we've got the two coordinates. Now we're left with the other coordinate, which is the c. C lies in which triangle? This triangle over here. And remember the line OC, which happens to be the radius, makes an angle of what? Alpha minus beta, right, with the x-axis. So we're going to say, okay, now what is the x here, and what is the, this is the y, so what is the y here, and what is the x here? So we can start with the x or the y, doesn't matter. So x, this, right, from here to there, that's x, over the hypotenuse, which is just 1. Remember, this is a unit circle. This hypotenuse is the radius. So, and the radius of the circle is 1. So x over 1 is equal to what? X over 1. So it's adjacent over hypotenuse. So this is the cosine of the angle in between the x-axis and OC, which is alpha minus beta this time around. Therefore, x is just the cosine of alpha minus beta. So now let's look for y. Remember, y is this side. So y over the hypotenuse, y over the hypotenuse, which is OC. OC is just 1. So y over 1 is equal to what? Y, which is opposite over hypotenuse. That is the sine of what? Alpha minus beta. So therefore y is simply equal to what? Sine alpha minus beta. So meaning that here the c, it's actually, so x is what? Cosine of alpha minus beta, and the y is sine of alpha minus beta. Okay, so that's that. Now we've got the coordinates a, b, and c, and we're good to go. So what I need you guys to pay attention to now is the fact that there's triangles which are congruent. If you check triangle OB, let's just say OAB, right? So OAB, so triangle OAB, OAB, and remember the angle between OB and OC, it's alpha minus beta, and also so in triangle AOB and triangle what? This triangle over here, which we'll call we said AOB. Let's just say it's DOC. So if you check, yeah, because we're talking about this one this time around, this triangle. So DOC, OC. So if you check in these triangles, right? In these triangles, OB is actually equal to OC. Do you understand? So OB is equal to OC. That's radii. Also, OA is equal to what? Check OA. OA is equal to OD, because remember, from O to D, that's a distance from the center of the circle to the circumference of the circle. So that's a radius. So OA is equal to OD, and it's still radii. All right. And then we also have an angle, right? Which is what? BOA is equal to COD, which is equal to alpha minus beta. Okay, remember this is alpha minus beta. Also, that is alpha minus beta. Okay, the angle between OB and OA. Okay, so therefore triangle OAB is congruent. Okay, is congruent to what? Triangle DOC. Right, what is the reason for that? We've got side, angle, side. So two sides are equal, and one pair of angles also equal. So we can then conclude that if the two triangles are congruent, right? If the two triangles are congruent, so this triangle and that triangle, that means that the third side, right? The third side, AB and CD. So AB is equal to what? CD, right? AB is equal to CD. Because I mean, the other two have actually proven that they're equal. So AB is equal to CD. What is the reason for that? Congruent triangles. Congruent triangles. So if the two are equal, then we're on to something. Okay, if the two are equal, AB and CD are equal, then we want to something. So we're going to say, fine, let's do this. Let's find the length of AB and CD. Right, let's find the length of AB and CD. So, but you know, you already have the coordinates of A, B, C, and D. So we'll look for A. You guys can see that A is just what? A is just the cos of alpha, sine of alpha, right? B, cos of beta, sine of beta. All right, so let's copy that. So A, it's cos of alpha, sine of alpha. B, that's cos of beta, sine of beta. And then C, that's cos of alpha minus beta, sine of alpha minus beta. I'll show you guys synthesis. Remember, the C, cos of alpha minus beta, the sine of alpha minus beta. Yes. And then the D, it's simply what? The D, it's simply 1:0. Okay, 1:0. So our D is 1:0. So now we're ready to get the ball rolling. So let's find, remember we concluded that AB is equal to CD. So what is the length of AB? Okay, we know that AB squared can be given by this. This is the distance formula. So let's find the distance between A and B. So it's going to be x1 minus x2 squared plus y1 minus y2 squared. So x1, it's cos of alpha, so let's just say cos of alpha. So square root of, so this is just let's get rid of this, but this is out. Okay, AB is equal to that, fine. So cos alpha minus cos beta squared, and then cos alpha minus cos beta squared, and then plus now we go into the y values, sin alpha minus sin beta, sin alpha minus sin beta squared. All right, that's what we have. That's our AB. Okay, and then now let's check. Okay, we've got our AB. Let's find our CD. CD. So CD must be equal to, we're using the same formula, x1 minus x2 squared. So what is x1? What is x1? So this we'll call our x1 minus x2, which is the 1. Remember, we're finding the length CD. Okay, the length CD. So this is x1, the 1 is x2, this is y1, the 0 is y2. So we're going to say fine, this is what we have. So we've got the cosine of alpha minus beta, which is just x1 minus 1 squared, plus the sine of alpha minus beta, right, and then minus the 0, which is y2 squared. Okay, so that's our CD. So but we know that AB and CD are equal, so meaning that this whole expression here is equal to that whole expression there. So we're going to say, okay, the square root of cos alpha minus cos beta squared plus sin alpha minus sin beta squared, right, is equal to, so remember this is AB, and then CD is equal to that cos alpha minus beta minus 1 squared plus sin alpha minus beta, sin alpha minus beta squared. Remember there we're subtracting a 0, so it doesn't make that much of a difference. So now that we've got this, we can remove the square root. Okay, we'll remove the square root, so we square both sides, square both sides, so the square roots fall off. So now we can start simplifying this. Cos alpha and cos beta squared. Okay, so this becomes what? Cos alpha squared minus 2 cos alpha cos beta plus cos squared beta, right, and then plus sin alpha squared, right, minus 2 sin alpha sin beta, and then plus sin squared beta. So this is just the left hand side, and then this is equal to the right hand side, which is just cos of alpha minus b, right, minus 1. So we're going to simplify that square there. So we're going to have cos squared alpha minus beta, right, cos squared alpha minus beta, and then minus 2 cos alpha minus beta plus 1, right, plus 1. So this is that term over there, and then we're simply going to add plus sine alpha minus beta squared, that last term there. So now we need to simplify. So let's check on the left hand side if you can't have any like terms. So you can see that there's cos squared alpha there and sine squared alpha there. There's also cos squared beta there and sine squared beta. So this pair gives us a 1, even that pair gives us a 1. Can you guys see that? So that's the square identity. So on the left hand side we're going to have so this and that give us a 1, this and that they give us a 1, cos squared beta and sine squared beta also they give us a 1. So 2 1s, that's like 2, right, that's just 2. And then now let's check what we left with, because this is out, the square terms are out. Okay, so we are just left with this on the left hand side. So we've got minus 2 cos alpha cos beta and minus 2 sine what, alpha sine beta. Okay, that's what we have. And then what we can do is we can then go to the right hand side and try to simplify. So cos squared alpha minus beta sine squared alpha minus beta, remember this is still the square identity, this is still the square identity. So the 2 are actually going to give us a 1. All right, the 2 are going to give us a 1, and plus the 1, it's going to be a 2. So we've got 2 minus the 2 cosine of alpha minus beta, right? So now if you check, this 2 and that 2 over there, they cancel out. So this and that, they cancel out. So we divide throughout by negative 2. So divide by negative 2, we left with what? The cosine of alpha minus beta, right? On the right hand side, if you divide by negative 2, the negative 2 here falls out and the negative 2 there falls out. We're going to have a plus. So we're going to have the cosine of alpha, cosine of beta, plus the sine of alpha, the sine of beta. And that is the identity, ladies and gentlemen. And on our next lesson, this is what we're going to be building up on. So we're going to be using the very same identity to derive the other identities. Okay, so cosine of alpha minus beta is equal to the cosine of alpha, cosine of beta plus sine of alpha and the sine of beta. So that's it for this episode, and I hope you guys enjoyed the lesson. And if you got lost, feel free to throw some questions in the chat, in the comment section. Maybe you might be found, you never know. Let's go.